Welcome to Gumber's Mathematics classes. Hope you liked the video. Subscribe our channel and press the bell icon to never miss another updates.
Hello everyone, I hope you all are well. Today we are going to discuss about the questions based on types of relations. Very first we'll recall what are the different types of relation. Very first is reflexive relation. A relation is said to be reflexive if every element of set A is related to itself. Then only we can say that the relation is reflexive. The main point is every element of A belongs to set A on which we are defining the relation. If there is any one element which is not related to itself in that relation, then this relation is not reflexive. Second thing is symmetric relation. The relation is called symmetric relation if A1 is related to A2 as well as with the same relation A2 is related to A1. Then we can say that the relation is symmetric. Third is transitive relation. If A is related to A1 is related to A2 and A2 is related to A3, as well as if A1 is related to A3, then the relation is called transitive. If there is no such combination that A1 is related to A2 and A2 is related to someone, if there is no such combination, then also the relation is transitive relation. And it should be true for all A1, A2 and A3 belongs to A. Next is combination of these three relations. Equivalence relation. Equivalence relation is a relation which is reflexive, symmetric as well as transitive. If a relation is reflexive, symmetric and transitive, then we can say that the relation is equivalence relation. Now we are going to solve the questions on this. Determine whether each of the following relations are reflexive, symmetric and transitive. Let's consider first. We are supposed to determine whether these are reflexive, symmetric or transitive. Very first, relation R on set A such that 1 to 14 counting defined by x and y are related such that 3x minus y is equal to 0. We can rewrite this relation as 3x is equal to y. Means second element is the third 3 times of first element. Then these are related to each other. Very first we will try to understand with the help of ray diagram 1, 2, 3 up to 14. And here also 1, 2, 3 up to 14. Then 1 is related to 3 because 3 times of first element is equal to second element. Next is 2 is related to 6, 3 is related to 9 and 4 is related to 12. 5 is related to 15 but 15 is not here. It means only these many relations related to 1 are here. Now we are supposed to check whether R is reflexive. R is reflexive means is 1 related to 1. As A belongs to A, 1 belongs to A. So is 1 also is related with this relation R. Is 1 3 times of itself? No. Therefore, this relation is not reflexive. Next is second, symmetric. We will be checking it for symmetric. As we can see that 1 is related to 3. Does 3 is related to 1? No, because 3 is not 3 times of 1 is not 3 times of 3. Therefore, this is not related to R. It means here AB is related to relation R, but BA is not related to the same relation R. Therefore, it is not symmetric. not symmetric. Next, third thing is transitive. Transitive means 1 is related to, here we can see that 1 is related to 3, 3 is related to 9. Is 1 related to 9? Is 9 3 times of 1? No, it does not relate to the relation R. These two relates to R, but 1 is not related to 9. Therefore, this is also not transitive. Next question. Relation R in a set N of natural number is defined as, this is the collection of all natural numbers and again natural numbers, and the relation is y is equal to, second element is equal to first element plus 5. First element plus 5, let us consider 1, 1 will go to 6, but we have to add 5 in this, and x is less than 4 only, it means we have to work for 1, 2 and 3 only. 2 will go to 7 with the same relation and 3 will go to 8, and rest of the elements are not related. Now we have to check whether it is reflexive, symmetric or transitive. Very first, reflexivity. Is 1 related to 1? No, 1 is not related to 1, therefore this is not reflexive. Next is, as 1 is related to 6, 1 related to 6, but 6 is not related to 1. Why? Because 6 is 5 more than 1, but 1 is not 5 more than 6. Therefore, it is not symmetric relation. Next is transitive. So, as we can see that 1 is belonging to 6 and 6 is not here to belong someone else. There is nothing is here. So, there is, and another also 2 is related to 7, but 7 is not related to anyone, and 3 is related to 8. 8 is also not related to anyone. Therefore, this is transitive relation. Transitive relation. Next is a relation R in a set A 1, 2, 3, 4, 5, 6 as y is divisible by x. Y is divisible by x means y is multiple and x is factor. 1, 2, 3, 4, 5, 6. Here also 1, 2, 3, 4, 5, 6. X is the factor of y, we can say this. So, let us check whether it is reflexive, symmetric or transitive or not. It would be reflexive if every element is related to itself. Means, let us consider 1 is to 1. Is 1 itself a factor of 1 or 1 is the multiple of 1? Is it true for every element? Yes, it is true for every element. A belongs to A is related to A. For all, A belongs to A. Every element is the factor of itself. Next is, it means it is reflexive. Next is symmetric. Symmetric means as 1 belongs to 2, because 1 is the factor of 2, this belongs to relation. Do we say that 2 is also related to 1? 2 is also the factor of 1. 2 is the factor of 1. No. It means this is not related to R. 2 is not related to 1. Therefore, it is not symmetric. This is not symmetric. Now, let us check it for transitivity. If A is the factor of B, okay, and B is the factor of C, okay, do we say that A is the factor of C in this? Yes, if it is there, if it is so, then definitely this also is true. If there is no combination like this, then there is no problem. So yes, this is transitive also. Let's check an example. As 1 is the factor of 2, 2 is the factor of 4, we can say that 1 is the factor of 4. Yes, it is transitive. Next is fourth. relation R in the set of integers of all integers defined as z minus x minus y is an integer. It means he is asking about integers are closed under addition and subtraction or not. Yes, these are closed. Every time whenever we are subtracting two integers, we will be getting an integer only. So we have to check whether it is reflexive, symmetric or transitive or not. Means if we subtract, if A is A related to A for all A belongs to Z, definitely. It means when we subtract these two means A minus A, and this is equal to 0, and this belongs to integers. It means A is related to A for all A belongs to Z, therefore this is reflexive. Next is symmetric. Symmetric means if A is related to B, do B also relate to A? Yes, definitely. Why? If A is related to B, it means A minus B is an integer. So no doubt B minus A is nothing else. This is the minus A B only. It means this is also an integer. So definitely these two are also related. Hence this is also symmetric. Next is transitive. Let A belongs to B. A is related to B. B is related to C, because it is a set of all integers. It will happen. Now we have to check. We need to check whether A and C are also related. Let's see. A and B are related to each other. It means B minus A is some integer. Let's say D. And B and C are also related. It means C minus B is also an integer. Let's say E. What we need to check for A and C means we need to check their subtraction. Is it an integer or not? What is C minus A? We need to find C minus A. For this we add and subtract B in this. C minus B is equal to E from here, and B minus A is equal to D. And if we add two of the integers, definitely we will get some integer. F is also an integer. It means this also says C is related to A. A is related to C. Here, yes, it is also transitive. Next is last part. Relation R in the set A on of human being in a town at a particular time given by. We have to straightway check, is it reflexive, symmetric or transitive. X and X work at a same place. Is it reflexive? Means do X and X for all X belongs to the set A, do these also work at same place? X is also working with X. Definitely yes, and it is true for all. Same person is working with same person. He himself is working with himself. Yes, it is reflexive. Next, if X is working with Y, can we say that Y is working with X? If X is working with Y, Y is also working with X. Definitely, and it is true for all also. It is symmetric also. Next, third is it transitive? Transitive means if X is working with Y, Y is working with Z, can we say that X is working with Z and for all? Yes, it is true for all, therefore it is transitive also. Next is second part. So first relation, A part is equivalence relation. Next is B part, X and Y live in the same locality. This is same as the first part. The question was working at same place, now here living at same locality. So this is also similarly reflexive, symmetric as well as transitive. Next is third part. Third part is X is exactly 7 cm taller than Y. x is 7 centimeter taller than y. It means x is equal to y plus 7. We need to check, is it reflexive, symmetric and transitive? Means a person, is he related to himself? Means, is he himself greater than 7 by himself? No, this is not reflexive. These may be equal, but one is not greater than himself. So this is not reflexive. Next is symmetric. Symmetric means if x is related to y, can we say that y is also related to x? If x is 7 centimeter taller than y, can we say that y is also 7 centimeter taller than x? No, we cannot say this, therefore it is not symmetric. Next, transitive. If x is related to y is related to z, can we say that x is related to z? See, no, this also no. Why? Because x is 7 more than y and y is 7 more than z. So, what is the relation actually between this? X is 14 more than z. This is not 7 more than. Therefore, it is not related to the given relation. It is not the member of the given relation. Therefore, it is neither reflexive nor symmetric and not transitive. Next is very important part. Next is wife of. We will check it for reflexive, symmetric and transitive. X is the wife of y. Can we say that x herself is the wife of herself? No, this is not true. Therefore, this is not reflexive. Symmetric. If x is the wife of y, can we say that y is the wife of x? No, y is not the wife. Y is the husband. Therefore, it is also not belongs to the given relation. This belongs, this doesn't belong. It means this is not symmetric. Next, is it transitive? Means if x is the wife of y, and is there any possibility that y is wife of someone? No, this is not the possibility. There is no such combination that y is the wife of some. It could be husband of, and can be husband of her only, x only. So there is no such combination for checking the transitivity. Therefore, it is transitive. Next is last part of this. Last part is x and y. X is the father of y. Let's see. Is x father of himself? No. Therefore, it is not reflexive. Symmetric. For symmetric, let us consider x is the father of y. Can we say that y is the father of x? No, y is not the father of x. Y is son of x. So this is also not symmetric. Transitivity. Let us consider x is the father of y is the father of z. X is the father of y is the father of z. Can we conclude that x is the father of z? No, x is not the father of z. X is the grandfather of z. It means this is not transitive. It's neither reflexive nor symmetric and nor transitive. It's okay. Bye-bye. Stay at home. Stay safe. Take care.